Welcome, guys. So this video, let's talk about the Chebyshev's sum inequality. Yeah, I mean, I just copied from Wikipedia. I mean, for this theorem. But in this video, let's dive in the proof. Okay, and we may talk some example of how to use this inequality to solving some interesting questions. So this inequality say that if you have n numbers a1 greater or equal to a2 up to an and b1 up to bn, and they are both decreasing, then you have you have this inequality 1 over n. You just inner product, right? You can use it as a vector. Inner product left hand side is the same as sum over it, and so average. Yeah. So and similarity, if you have if you change 1 to be decreasing, then you have inverse. Okay, so let's quickly see the proof from here to here. Okay, so to here is very easy. You just change a1 to minus a1, right? So suppose you originally have this, and then you will map to this. Then you can change it to this. Right, so if you change a1 into negative a1 and a2 into negative a2, then this original inequality will get a minus sign here. And the minus, if you times minus 1, then you change the sign of inequality. Okay, so that means this second one is the same as the first one, right? So we only need to assume that we only need to prove the first one. Okay, so so everybody remember this inequality. Okay, so okay, so let's go to the proof. Okay, so the idea, let's see. Right, so we have a1 to an, right? So idea is that let's define S to be aj minus ak, bj minus bk, such that j from 1 to n, k from 1 to n. Okay, notice this. So notice this term, right? This term, aj minus ak, bj minus bk. So notice this term. Okay, so when j greater than k, then aj minus ak is greater than 0. Also bj greater or equal to 0. bj minus bk is greater or equal to 0, right? And when j less than k, then this term will be negative, and this term will be negative. So negative times negative will still be positive. So each term in this S expansion is greater or equal to 0, right? So yeah, so that means S is greater to 0, and we can do the expansion of this. So you become AJBJ, AJBK, AKBJ, AKBK. Okay. Maybe I change this. Okay, so this become right. So you see this term only contains AJBJ, right? So now k from 1 to n will give us n. So it goes just n, j from 1 to n, aj, bj. And also this term is the same, right? So you get 2n, j from 1 to n, aj, bj. Just using change the dummy variable from k to j. And then you have like this, k from n, j from n, aj, bk, plus k from n, j from n, ak, bj. Right? And these two terms, j and k, are separated, right? So I can change it into this. Right, and this term is the same as this, right? Because just change the dummy variable, so we can just times times 2. Okay. Right, greater or equal to 0. So that means aj, bj, j from 1 to n, n greater or equal to aj, j from 1 to n, bk, k from 1 to n, and divided n square both sides, right? So you get a j from 1 to n, 1 over n, greater or equal to 1 over n, a j from 1 to n, times bk, k from 1 to n, 1 over n. Sorry, let me just write clearly. I don't know why the pen looks like this. Maybe I need to change a little bit. Okay. What the hell is this? Okay, so you see these are two terms, right? So yeah, so we prove this inequality. Okay, so once you prove the first one, as I said, you just change a1 to negative sign. You prove your next. Okay, so I should say there are many inequality. The first one is the geometric mean greater or equal to the average the arithmetic mean greater or equal to geometric mean, and the Cauchy inequality, and also the Chebyshev sum. And there are other interesting inequality like Holder's inequality, Young's inequality. And basically, I will leave a playlist. Basically, I prove some elementary inequalities in the video. I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.